Hey guys! In this video we're going to discuss the quotient rule. Now the quotient rule is for when you have two polynomials that are being divided. So I actually did the way that I wrote this formula this way on purpose. It's actually not that different than the power rule, the product rule that we learned in the previous video, as long as you write it this way. The power rule, I keep saying that wrong, don't I? The power rule says if you've got two things being multiplied, that their derivative is f prime g plus fg prime. Well, the quotient rule is very, very similar. If you've got two things being divided, their derivative will be f prime g minus fg prime all over g squared. So once again, we can do this two different ways, especially if it's very simple like this first example here. We can just go ahead and divide out by t, which will give us t to the 8th minus 6t plus 8 over t, otherwise known as 8t to the negative 1, and then we could find the derivative from there, which is arguably easier. But let's say for the sake of argument that we can't, that this is just too complicated and we don't want to do that. So we are going to do this using our quotient rule. So the top will be f and the bottom will be g. So f prime would be 9t to the 8th minus 12t, and g prime would be just 1. So we put this into our formula. F prime times g of, t, minus, now be careful, this does have a minus in the formula. So when you subtract, make sure that you are subtracting correctly. Otherwise, you'll have some problems. Times g prime. Now, because of how long these things can get, I will, by personal preference, just say, okay, and I have to divide by g squared as a personal reminder so that I can simplify my numerator as much as possible before I start worrying about my denominator. And that's just a personal preference to help me, but you can do it the other way as well. So let's go ahead and simplify this. So we have 9t to the 9th minus 12t squared minus t to the 9th plus 6t squared minus 8. Combine like terms. So I have 8t to the 9th minus 6t squared minus 8. And that is still all divided by g squared, which in our lovely case is g is t, so g squared would be t squared, and I'm dividing by a monomial so I can simplify this, and that will give me a lovely 8t to the 7 minus 6 minus 8t to the negative 2, which makes perfect sense considering that our original could simplify down to t to the 8 minus 6t plus 8t to the negative 1. If we use the power rule and got the derivative from that way, then we would get the exact same answer, as we should. So this is just another way of doing the derivative for quotients, but it's more specific to the fact of when we have something complicated that we can't really simplify well. So let's take a look at the next one. We have the derivative and we have division. So we have something that we can't really simplify this, not easily. So we call the top f, so f's prime would be just 2e to the x. Don't we just love e to the x derivatives? G prime would be 7e to the x. And then we can use our formula. So f prime g minus fg prime divided by g squared. Okay, so f prime times g minus f. Careful of your mistakes. G prime, and then divided by g squared. Okay, so simplify. So we have 14e to the 2x plus 10e to the x minus 14e to the 2x. Combine like terms, so that's 10e to the x, and then divided by g squared. So this would be divided by 7e to the x plus 5 squared. And I can't simplify that anymore, so I'm done. If you can simplify more, you are expected to. If you can't, then you're fine. So let's have one more example, and this one's a bit more interesting. So just looking at it, offhand, we have a small problem. We have both a fraction, which would mean the quotient rule, but we also have, in our denominator here, we have the product. So we would need both the product and the quotient rule to make this work correctly. Ouch. Good thing we use color coding. So, f prime is easy enough. That's just 1. But for g prime, I would need the power rule. So, f prime g plus fg prime. So if this bit up front is my f and this bit behind is my g, just for this one little piece, so f prime would be 16x and g prime would be e to the x. So the blue g prime would be f prime times g plus f g prime. Okay. And that is the blue, all told. So now we can do the quotient in its entirety. So, let's back to the blue. F prime times g minus f g prime, the blue g prime this time, alright, all over g squared. Let's simplify. Okay, so let's see here. So we have goodness, that's a bit. Okay, let's do it. 2 steps. 2 steps. Alright. Do. There, distribute the negative. And yes, some things just take a little bit. Okay. Combine like terms. So we have, let's see here, negative 8, that, 16x squared e to the x, plus 48x e to the x. And this is all over g squared. So 8x squared e to the x squared. And I can't really tell if I can simplify that or not. So let's go ahead and square it. So that would be 64x to the 4th e to the 2x. Okay, so yeah, I can actually simplify that, can't I? Not by much, but I can. This top part here, let's rewrite this. Make it a little bit easier for us. We can pull out a GCF in our numerator. So that'd be negative 8x e to the x. So that gives us x squared minus 2x minus 6. And we can divide that with our denominator there. That's right. Okay. So that'll still give us a negative. And our denominator would go down to 8x cubed e to the x. So that would be our full derivative for whatever we were talking about. What is it? H? So this would be our official h prime of x. So sometimes you have to use more than one derivative rule at a time to get what you need. But that's okay, as long as you make sure you are methodical, do it step by step, don't forget anything, and don't try to do anything in your head. The more you do in your head, the more headaches you're going to get.